In this section, we're going to learn to complete the square, and in order to solve a quadratic form in the quadratic equation in the form ax squared plus bx plus c is equal to 0. First step, if a is not equal to 1, go ahead and divide all the terms in the equation by that coefficient. We want the x squared coefficient to be 1. Second, isolate the constant term c on one side of the equation, so move it if it's not already on that side. Then third, complete the square and balance the equation. Let's go this far with our first example, which says example 2. All right, so a is 1 in this. We have a 1 in front of that x squared, so we're going to leave it. We're not going to do step 1. Step 2, we're going to isolate the constant term. That is to say, we are going to subtract 4 from both sides of the equation. That'll give us x squared minus 2x equals negative 4. The next thing that we're going to do is we're going to put a plus blank on both sides of the equation. Then we're going to complete the square. And I use a box to complete my square. It's more of a literal square. And I write the first term in the upper left corner. Then I take that middle term and I divide it into 2 equal pieces. Negative 2x divided into 2 equal pieces is negative 1x and negative 1x. Then we're going to try to construct the factors. Now, the factors for a square need to be identical. So x times x is x squared. The first term in each binomial is x. And then x times the next factor needs to be negative 1x. So the next term in each binomial is negative 1. Now, multiplying those negative 1's together, we get positive 1, and that will complete the square. Next, we're going to rewrite the trinomial as a binomial squared. So that means x squared minus 2x plus 1 can be rewritten as x minus 1 squared. And then we're going to go ahead and combine the terms on the right side to get negative 3. Next, we'll solve by taking a square root. So if x minus 1 squared is negative 3, then x minus 1 can be I times the square root of 3, or x minus 1 can be the negative I times the square root of 3. So adding 1 plus I root 3, adding 1, x equals 1 minus I root 3. So our solution set contains 2 conjugate solutions, 1 plus I root 3 and 1 minus I root 3. Let's try the next one. M squared plus 6m plus 11 equals 0. This one, again, the first coefficient is 1, so we're good there. We're just going to move that 11 to the other side of the equation, and I'm going to go ahead and put my plus blank on both sides. So we'll have m squared plus 6m equals negative 11. Then I'm going to go ahead and complete that square using a box. So I've got m squared in the upper left box. Divide that 6m into 2 equal pieces. That's 3m and 3m. When we construct the factors, that's going to be m and m for the first terms of each binomial, and 3 and 3 for the second terms of each binomial. Completing the square, there's a 9 in that last box. That's what we're going to add in each plus blank. Okay, so we've got m plus 3 squared equals negative 2. And now taking a square root, m plus 3 is either equal to I root 2. It's not a real number because we're taking the square root of a negative. Or m plus 3 is equal to negative I root 2. All right, subtracting 3, m is negative 3 plus I root 2, or m is negative 3 minus I root 2. So our solution set, again, contains 2 conjugate solutions. All right, now your turn to try. Try A below on your own and stop the video. All right, this one produced 2 conjugate solutions again, but these were real solutions since we were taking the square root of a positive number. All right, try 2 on your own. All right, for this one, two conjugate solutions again, -4 plus 2i and -4 minus 2i. All right, let's move on to another example in which we'll have to make the first coefficient 1. Completing the square hinges upon that first coefficient being 1, so let's make the first coefficient 1 by dividing both sides of the equation by 3. That's going to give us x squared minus 2/3 x plus blank equals 1 plus blank. We didn't have to worry about the constant term being on the right side of the equation because we already moved it, or it was already moved there. Now I'm going to put my terms in the boxes here. Now I've got to divide 2/3 into two equal pieces. That would be -1/3 x and -1/3 x in each box. So constructing the factors, x minus 1/3 and x minus 1/3. That puts a 1/9 in the blank, or 1/9 is what we're adding to both sides of the equation to complete the square. So x minus 2/3, x squared minus 2/3 x plus 1/9 is x minus 1/3 squared, and 1 plus 1/9 is 9/9 plus 1/9, or 10/9. So that means that x minus 1/3 can be either the positive square root of 10 over 3, taking the square root of the numerator and the denominator, or x minus 1/3 can be the negative square root of 10 over 3. Now what you'll notice when you add 1/3 to both sides of the equation is the both expressions have a denominator of 3, so we can put them together into one fraction, 1 plus the square root of 10 over 3, adding the numerators and keeping the denominators. And then our second solution would be 1 minus the square root of 10 over 3. So again, we get these conjugate solutions. All right, let's try another one. This one, we need to divide both sides of this equation by 8 to produce a first coefficient that's equal to 1. Let's reduce the fraction 12 over 8. That would be 3 over 2. And then that 1/8 will need to move to the other side of the equation, so I'm going to subtract the 1/8 from both sides and insert my plus blanks. Now let's complete the square, d squared in the upper left. And then I need to take 3/2 and divide it into two equal pieces. Now, probably the easier way to think of this is taking 1/2 of, or multiplying 3/2 by 1/2. So that'd give us 3/4 times d in each one of these parentheses. So d, 3/4, 3/4. So that means that when we complete the square, we have 9/16 in that last box. So I'll add 9/16 to both sides of the equation. Completing the square, we have d plus 3/4 squared equals, and now over here on the right side, we're going to need a common denominator. So that's -2/16 plus 9/16. So d plus 3/4 squared is equal to 7/16. Now we're going to take our square root. D plus 3/4 equals the square root of 7 over 4. Or d plus 3/4 equals the negative square root of 7 over 4. Again, you're going to notice that both of our numeric terms have a denominator of 4, so when we subtract 3/4, we're going to get solutions that we can put together into one fraction. We subtracted 3 from both sides, so that's the reason why our 3 is negative there. All right, your turn to try the ones below. Here are the solutions to this one. Now when you try B, we're going to be dividing by 1/2. Now think about this. Dividing by half is equivalent to multiplying by 2. So start there. Okay, there are solutions 4 plus 2 root 5 and 4 minus 2 root 5. In the last part of this lesson, we're going to look at equations that don't look quadratic to begin with. So let's take a look at this one. W over 2 minus 5 equals 4 over W. Well, there's fractions in there, and we really would rather not solve an equation that has fractions in it. Rather, we need to multiply through by the LCD. So if there are two denominators, 2 and W, then the LCD is 2W. 2W times W over 2, the 2's cancel. That leaves us with W squared. Then 2W times 5 is 10W. And then on the right side of the equation, the W's will cancel, and 4 times 2 is 8. So now we've got a perfect complete the square type of equation. So let's complete the square. W squared, and then that negative 10W middle term could split into two equal pieces, minus 5W and minus 5W. Constructing the factors W minus 5 and W minus 5. Completing the square, positive 25. So we're going to add that to both sides. And then we've got a W minus 5 squared equals 33. That's going to give you W minus 5 is equal to, and I'm going to use a little shorthand here, plus or minus the square root of 33. So when we add 5 to both sides, we get 5 plus the square root of 33 and 5 minus the square root of 33. The plus or minus goes on the square root, so that's where we get our two solutions from. A little easier way to write that. All right, let's do another one. X over 3 plus 15 over x equals 4. There are two denominators again, and so we need to multiply both sides of the equation by 3 times x. When we multiply to the first fraction, the 3's cancel, leaves us with x squared. To the second fraction, the x's cancel, leaves us with 3 times 15 is 45. And on the right side, 4 times 3x is 12x. We need to do a little bit of rearranging. Let's subtract that 12x to the left side to be with the x squared. And let's subtract the 45 to be on the right side. And I will put a plus blank on both sides, dividing the middle term into pieces, minus 6x and minus 6x. Let's construct the factors. They're x minus 6 and x minus 6. Completing the square, that gives us a positive 36. So x minus 6 squared is equal to negative, what is that, negative 9? Yes. And so when we take a square root of a negative 9, we're going to get an imaginary number. So x minus 6 is equal to plus or minus 3i. So that'll give us 6 plus 3i as one of the solutions, and 6 minus 3i as the other solution. All right, a couple for you to try. Try A below. All right, here's the solution to the first one, negative 7 plus or minus 5 root 2. Now try the second one. And there's the answer for the last example. 2 minus 6i and 2 plus 6i are the solutions to that equation. And that wraps it up for this section. One more thing to go, that's the quadratic formula.